Alright, I want to talk about section 10.15. This time we're going to be talking about volume of cones. There's some interesting connections between our cones and our pyramids, and we'll see kind of how that works in our formula. First, remember that the cone is this ice cream shape. Not the actual ice cream, but where you put the ice cream. And what you'll notice is that this is very similar to one of our other shapes, a shape of called our cylinder. Our cylinder, remember, looks like this. And we're actually going to use our formula for our cylinder to craft the formula for our cone in almost the same way that we did with our pyramid. So whenever we're finding volume, what we really do is we find the area of the base, and in this case all we need is r, and then we're going to find the big height, and we're going to kind of draw it up. Just like in that Tinkercad example where we built a circle and then we kind of stretched it up to take up actual physical space in 3 dimensions. So our volume of our cylinder, remember, looks like this. We start with the area of the base, and the area of the base in this case is that we start with a circle, and the area of a circle is pi r squared. So all we do is we take this pi r squared, and then we multiply that by the height in order to draw it up. But this is again for the cylinder, and it doesn't help us so much with the cone, and the cone is our actual goal in this case. But we'll notice that we can do something very similar that we can do just like with the pyramid and the cube. Now if I draw a cylinder, and I can fit my cone inside of this. So if I do the center of the pyramid here, and let me use a different color this time, I can actually build my cone, if I think of it as, kind of here as well. And notice how it kind of fits inside this cylinder. And if I built it perfectly and kind of built it exactly what I would need, I could do the same experiment that I did before, where I could take these two and fill them up with water, and I could dump them into the larger cylinder. And what I would notice is that it takes three cones to fill a cylinder. And that's going to mean that if I want the volume of just one of these cylinders, I'm just going to take 1/3 of the total volume of the cylinder. So my volume of my cone, in this case, is very simply the volume of a cylinder, pi r squared times h, times 1/3, just like what we did before. And this is how we can get to our volume of a cone, and it is pretty easy to do this. Let's take a look at a quick example. If you feel like you probably understand, you can go on without me, but I'll build a quick cone for our example. With our cone, I only need 2 measurements. I need the radius, which in this case is 5 inches. And I also need the height of my cone, which in this case is 7 inches. Let's put it in our formula and see how it works. I always like to write my formula out first because it makes sure that I have it all written correctly. My volume of a cone is 1/3 pi r squared times my big height. Okay, 1/3 times pi times my radius of 5 inches squared times my height of 7 inches. 5 inches squared is going to be 1/3 times pi times 25 inches squared. Remember that it's just the inches that are squared in this case, not the 25. I've already squared that one out. Times 7 inches. This time I'm going to do my 25 times 7, which is probably 175, but I'm just going to check to make sure. Using my little calculator. 25 times 7 is 175. And inches squared times inches is going to be inches cubed. And that's where my cubic will come from to represent my volume that I've got. I also have 175 pi, and I also have my 1/3. So I'm going to do 175 divided by 3, and I'm going to get about 58.3 pi inches cubed. In this case, I could leave it like this as 58.3 pi, or I could multiply by 3.14 and get about 183.2 inches cubed. Or I could even write this simpler at the beginning, and I could write this as 175 pi over 3 inches cubed. Any of these would work because they're all technically the same number. If I put all these on the number line, they would be exactly in the same spot. Well, ish, because we did do some rounding, but the idea still holds. Okay, if you feel like you get it, go on. I'm going to do one more quick example, and if you want to watch it, you're welcome to. I'll just do number 1 on the homework. Number 1, I have... Oh, I think I did that already. Let me find one that I like. We'll do a radius of 7 and a height of 13. Radius of 7 and a height of 13. First, I'm going to write out my formula. Volume of a cone is equal to 1/3 pi r squared times big H. 1/3 pi, substitute in my r of 7. In this case, I do have centimeters. Squared times 13 centimeters. 7 squared is 49 centimeters squared times 13 centimeters. 1/3 pi. 49 times 13. 49 times 13 is 637. I have 637 centimeters cubed divided by 3 times pi. So I'm going to do 637 times, first I'm going to divide by 3, 212.3 pi times 3.14 gets me about 666.7. And this is centimeters cubed. And that's how we do it. And this is the end of chapter 10, which is pretty exciting. And go ahead and good luck.